We'll go ahead and get started now. Good evening and welcome to the National University Speaker Series. First of all, I'd like to wish all of you a very happy new year. And I can promise you that in 2024, National University will have many interesting topics and a wide variety of notable presenters for our NU Speaker Series. My name is Nancy Rowland Heinrich, and I serve as the Executive Vice President of Communications and Community Engagement for National University. I am also proud to be the founder and host of our NU Speaker Series. We really appreciate all of you attending this evening. It's impressive to see all the different parts of the country that you're coming from, and we certainly welcome our international visitors as well. We understand that it's very late on the East Coast, but I hope that you find tonight's topic and speakers so enticing that it will be well worth staying up for. So whether you're a student, an alum, faculty, staff, or community member, we certainly welcome you. National is so committed to community and reaching out to all of our sectors. We just celebrated our 52nd anniversary, and we're currently serving more than 50,000 diverse students enrolled in more than 190 degree programs. Our alumni network now exceeds 230,000, all accomplished, dedicated professionals in diverse fields. But tonight we have a fascinating topic on unlocking the power of trust in the age of AI. Our speaker, Dr. Alexander Stevens, earned his PhD in technology and innovation with a data science subspecialty from North Central University. We're pleased to have an alum from National University and our sister institution. I would like to share a little bit more about Alex's background. He is dedicated to the studies of governance, trustworthiness, development, application, and human factors of artificial intelligence to drive adoption and maximize AI investment. Not too many people with that type of expertise. But due to the rapid maturation and deployment of advanced AI technologies such as generative AI, Alex developed a new theory of trust and acceptance of AI technology, acronym TRAIT, in healthcare transformation. He has applied the TRAIT system as an informatics tool to help to improve the adoption of clinical AI. Clearly, Alex is very accomplished in the healthcare field, and he thrives on leading the frontier to responsibly coalesce human ingenuity and innovation with people and organizational strategy. So with this cutting edge topic tonight, we know you will have many questions. So please note that following the presentation, we will have a moderated Q&A session. And today we are joined by one of my distinguished colleagues, Dr. Stephen Johnson, who will serve as the moderator for the discussion. Steve serves as the Senior Vice President of Innovation for National University. But at this time, it is my pleasure to turn the program over to Dr. Alexander Stevens as he shares more about trust and AI. Alex? You are muted.
Well, let me say that again. Good afternoon and good evening, everyone, and I hope everyone is doing well. Give me a moment while I bring up my slideshow. Bear with me now. I seem to be having trouble sharing my screen.
No problem, Alex. We've got a backup. Give us just a second.
Technical difficulties.
While we're waiting, I'd like to just mention again that we will have a Q&A session, but we ask that you put your questions in the Q&A rather than the chat so that our moderator can more easily access those questions.
Stand by. I think things might be coming around. Oh no, I'm viewing your screen, right?
Yes, we've shared the slide.
I've got it up, Alex. If you want to get started, I can just click through whenever you let me know.
Very well. Okay, we'll just go ahead and get started. So welcome to Unleashing the Power of Trust in the Age of AI. I am very honored to share this time with you, and I hope that you find something meaningful and valuable from our time together. Next slide, please. So we're going to journey through trust and trustworthiness this evening, and leadership and artificial intelligence, and we're going to talk about my new theory of trust and trustworthiness of artificial intelligence. So in this presentation, I'm going to focus mostly on what I call TNT, and that stands for trust and trustworthiness. And I'm going to assume that most of the folks in the audience have a really good or practical understanding of what leadership is. So we'll spend a little less time on that section. And really, the purpose of that section is to highlight its importance in the success of both an individual and an organization who wants to use and implement AI. And the reason I bring this section up is because, or the reason I included it rather, is because leadership is vital to the governance and the development, implementation, and responsible use of AI. And my true aim with this talk this evening is to make the connection between trust in a human and trust in a machine. In essence, I want to draw the parallel of how similar the traits are between the two, especially given how we choose to bestow human-like qualities in our AI partners. And we'll spend more time learning about what AI is before we move into my new theory called trait. And then we will hopefully see similarities between our TNT in people and in AI. And we'll wrap this session up with a robust Q&A session, hopefully. And note here, the section in AI, I'm going to avoid a deep technical or mathematical underpinnings in favor to focus more on a good understanding of its basics. Next slide, please. So I like to place learning objectives in the form of questions. So the 4 key questions that we have to keep in mind as we take this journey together are: what is trust? What makes a leader or AI trustworthy? And how do you evaluate the trustworthiness of a person or AI? And then lastly, how should the results be used to affect change? Now, this last question is a positive action step, and I believe that we should be prepared to establish and or improve a human relationship or the adoption of AI, because we should be focused on maximizing the value and benefit of our investments in one another and in our technology. The ultimate aim here, if you're a professional who wants a leadership role, you want to understand how to improve team cohesion, which leads to success. And if you're implementing AI, you want to make sure your outcomes impacted by your use of AI follow through with your ability to improve your team cohesion and maximize your investments in AI. Next slide, please. So hold on, don't reveal what's on that whiteboard yet. So before I reveal the definition here, I'd like to invite folks to reflect on your own experience and feelings of exposure and trust in their relationships. And I have a question for you, and I'd like to use a Menti word cloud here. And I would like to ask in one word, what are we willing to place in the hands of a person that we choose to trust? We're getting some responses through. We'll wait just another couple of minutes. Or another minute.
Yeah, Alex, did you want people to engage in the chat or do you want them to go to the mentee?
I wanted them to go to the mentee. I see them coming through on the chat.
Okay, perfect. We can do a blend. No worries.
We've got 18 responses in the mentee and a ton of responses in the chat. So some words that I see, I'm going to just continue on here. Unfortunately, I can't share my screen. So the big word in the middle is money. I love it. So I'm seeing words such as humility, honesty, fairness, confidence, transparency, integrity, fantastic, communication. All of these certainly have meaning with respect to what we're willing to hand over to somebody else who we want to give our trust to. If you could go ahead, please bring up the definition I have here. So the definition of trust is the extent to which a trustor, us, is willing to be vulnerable. The word I was looking for hopefully was vulnerable. All your other words are absolutely perfect. To another's actions, given the expectation that this person, the trustee, will act in our behalf with our best interests in mind. Very good. Okay, next slide, please. So, how do you earn it? Warmth. So the question pertains to each of us, especially when we first meet others who we'd like to earn their trust. These concepts and traits are defined in the stereotype content model, or SCM. When we first meet new people, their warmth is perceived when we assess their intention to either help or harm us. We have a tendency to want to do that when we first meet somebody, whether it's conscious or subconscious. And then our impressions of their competence is a result of judging their capacity to act relative to our understanding of their intention. Next slide, please. So once we've earned their trust or initiated their trust, why do people stay? Well, importantly, we have a few of these traits that we exhibit consistently. One is credibility, and credibility pertains to our believability. And where does credibility come from? We exhibit our expertise, our ability to act, which is competence. The consistent, demonstrable competence that we show other people underscore our believability, our credibility. And then by our role, the responsibilities we have in our role and our commitment to protect others, beneficence. It's our intention to act on other people's behalfs with the best interest of them in mind. And then one other little dynamic that I like to include here is our volitional authority. And this is our agency to voluntarily act on behalf of others, especially if you're a leader of a team. Next slide, please. Okay, so trust is a dynamic relationship. This represents trust in people between two humans. Trust is a dynamic relationship, and it's always under scrutiny by the trustor. We always evaluate the trustees' credibility, their beneficence and integrity, and their competence. We evaluate if we can bestow our trust in others based on our impressions about the trustee's attributes. Consequently, our human relationships, skepticism towards others, especially leaders, is natural and healthy. Next slide. So I would like to, hold on a second. I would like to do another mentee here. If you could please go to Menti. And the question here, before we get into leadership, is if you could describe the single most important skill or ability of a leader in a single word, what word would you use? Again, I'd like to do this in Menti. Feel free to go ahead and use the chat as well if you would like.
Hey, Alex, this is Steve. How do people get to Menti if they haven't used it before?
Menti.com. And the code, there's a code. You can see it on the slide there. And you go to Menti.com and you enter that code, and you should be taken directly to the presentation there. And if that's too difficult or not working for people, I'm happy to take comments in the chat.
Hey, Alex, it's Heather. I think we're having some trouble with the Menti. Do you mind just rolling with the chat for now?
Oh, sure.
Thanks.
See some coming in. So I'm seeing words like collaboration, vision, honesty, a visionary. That's key. Empowering others to maximize themselves and their outcomes. Absolutely. Transparent on their mistakes. Absolutely. Guidance and mentorship. Inspirational. Fantastic. So if we can continue on the slide. So I'm going to stop right there. So I'm going to bring up the evolutionary theory of leadership first. And it suggests that the purpose of leadership is to increase the efficiency of a group and to assure its survival. So specifically, leadership serves to coordinate the collective group thinking and behaviors to maximize group benefits and minimize costs. So that's the evolutionary reason as to what a leader is. Now, the perspective I'll share from the modern effective leader standpoint in this talk is that they view themselves as servant leaders. Now go ahead. So philosophically, they believe that there is a mutually and existentially beneficial relationship between the organization and its people, meaning the organization exists to serve its people as much as its people serve it in pursuit of its goal. So whoever fulfills this role must have a deep sense of responsibility. Next. Be clear about to whom and for what they are accountable. And a refined skill to influence others. These are inspirational, visionary leaders. They share their vision. So we still need a succinct definition of leadership. Next slide. It is a position of servitude that requires a deep sense of responsibility for the group's outcomes, fearless accountability for the group's results to the stakeholders, both internal and external, and the ability to strongly influence the group composition, behavior, and direction. Next slide. So what are the duties of a leader? So to me, it's to inspirationally share, rather, their vision, establish a positive, supportive culture, remove obstacles, and most importantly for me, because I'm a people person, coach, counsel, develop, and empower their team. Next slide. So what about their character? What are the qualities of effective leaders? And effective leaders are genuinely and authentically everything you see here. Perhaps most importantly, their genuineness emerges from reliably showcasing alignment of their words with their actions in pursuit of their vision. Next slide. So before we answer the question, why lead, I want to continue to talk about evolutionary leadership for a second. And that theory postulates that leadership naturally arises in groups to ensure the group's fitness, survival, and success, and to align the group's collective efforts with a specific purpose. Now, the theory posits that a leader emerges from the group when the collective members face fitness-relevant situations. And this allows the candidate leader to exhibit the context-specific leadership traits, their image, and their message. And the degree of influence that this person has on the group depends on the group's perception of their degree to which the leader's image fits the situation and the alignment of the leader's image with their message. So this brings us full circle. Why lead anyway? And it's an important question I think we all need to ask ourselves when we have the opportunity to take a formal leadership role or decide whether or not we should be an informal leader within our team. And this requires honest and sincere introspection. It's necessary to ensure we choose to lead for the right reasons. For me, it's about accomplishing something meaningful and valuable for a corny reason bigger than myself. That's my personal perspective on leadership. Next slide, please. So, I included leadership in this talk, again, to underscore that it's people who are responsible for AI. I'm very passionate about this piece. The decision to use it is up to people, to govern it is up to people, develop it, implement it, and manage it, life cycle. All people. The essence of AI is the human. I have shared this with my colleagues before. And our trust in it must start with the people we entrust with the skills to make those decisions and tools. AI is a tool. It's not a hammer. It's more like a Swiss Army knife. Zoom just quit on me unexpectedly. Am I back?
You're back. Thank you.
Oh, wonderful. Thank you. I apologize for that, folks. So the sheer volume of information on this topic about what is AI is overwhelming. And to start, where to start on it actually is a valid question. So we're going to begin at the beginning, and we're going to learn the non-mathematical basics and relationships of AI, machine learning, and deep learning. And we're going to pay special attention to the basics of artificial neural networks here. And so then we will move on to learn about large language models. And you'll find that the magic for these tools like ChatGPT, BART, and any others in their class comes from two main things, two important technologies. One are transformers, and the other is attention. And learning the non-mathematical basics of those hopefully should prime you to go further on your own and demystify why and how these cool tools appear to behave and respond more like us. Then you should see from that how these things are just mathematical manifestations of our ingenuity and creativity. They are far, far from being human. Next slide. So here's the question. What is AI really? And AI is a way of making computers programmatically behave like humans, do things like talking, or playing games, or seeing things, or solving problems, or having a conversation. And today, with generative AI, it's summarizing something for us, possibly, or doing our research, or creating a table of something. You can actually ask it to do that through prompts and be able to get back some very relevant and important information very quickly. So AI can help us learn new things as well. And we can make the world a better place with it as long as it's used appropriately. And the ethics of using AI, that again is up to us. We need to lay in the governance foundation before we implement it to make sure we're doing it safer and faster and appropriately. So how does it do this? You can think of AI as applying a set of rules mathematically and other mechanisms for the purpose of making inferences based on data. And the types of AI, as you can see here in this Venn diagram, we have artificial intelligence, which houses everything, machine learning, and deep learning. These items, these classes of AI are all related, but they are not the same thing. But when you talk with anybody, the general term is AI, and they could be referring to any one of them. So AI itself appears more human-like, as it can appear to think and learn like us, like recognizing our speech, context, playing games, and driving cars. Machine learning, it's a type of AI as well, and it learns from data like a student who learns from examples and feedback. And deep learning, it's a subset of machine learning, and it uses artificial neural networks to learn from data. Also, like a student who learns from examples and feedback, but also learns from many other students. Now, some key differences here about AI, ML, and deep learning is AI includes everything that involves making machines smart. Machine learning involves machines, teaching machines rather, to learn from data rather than being explicitly programmed to do something. And deep learning involves teaching machines to learn from data using artificial neural networks. And we're going to talk about that, and I'm going to show you a model, a very simple model of that here in a moment. Next slide, please. So different types of AI. So there are two ways that we teach artificial intelligence or machine learning algorithms. One is supervised learning, and the other is unsupervised learning. In the supervised learning, we are teaching it to make a prediction or a classification. We give it a labeled data set, meaning we give it inputs, and we tell it what the outputs are supposed to be. In unsupervised learning, we do clustering. We have it look and search in the data and find patterns and group things based on the pattern that it finds. Next slide, please. Supervised learning. So here we use labeled data, and you can see here in the very first arrow, you have your X's and your Y's. That's to represent a labeled data set. And we train that algorithm to predict an outcome. Then we validate that algorithm using a separate validation data set of the same type with labeled data and assess its performance and validation before we release it to production and call it a model. As you can see here, once the model is in production, it receives brand new data, untouched by us. We didn't do anything to it. It receives this new data into the model, and it makes either a prediction as it was supposed to, or it classifies it. Yes or no, A, B, C, this is a cat, this is a dog, et cetera, et cetera. So some examples of models that predict future sales volumes, for example, or sales demand, or prices based on prior data with known outcomes. And in production, the model can take this new data and yield its prediction. Or it could do things like predict the likelihood of disease, such as COVID, cancer, sepsis, or even morbidity. And there are some popular supervised learning algorithms. I'll name a few here, and I'll leave it up to you to do some further research on these. Linear and logistic regression models like sigmoid or hyperbolic tangent functions. Oh, by the way, in an upcoming slide, I'm going to give you an example when I talk about neural networks. And the activation function in there will be sigmoid. That's as deep as we're going to go with math. Decision trees could be another example of a supervised learning algorithm, and support vector machines. Next slide, please. So here's unsupervised learning. And clustering also uses unlabeled data to train, validate, and release a model that functions to find patterns in the data and infer something useful. For example, using social media and customer data sources for clustering customers based on similar buying patterns. Or using vehicular and smartphone GPS data to find fare hotspots to improve profitability for taxis. And we've got some popular, clustering algorithms. Could be K-means, BB-scan, and hierarchical clustering. Again, I'm going to encourage you to go ahead and do your own research if you want to get deeper into those. Next slide, please. Here we get into some really cool stuff, the stuff that everybody is conscious about today. And large language models like ChatGPT, which was released by OpenAI in late 2021, are essentially chatbots built as UIs or user interfaces over top of large language models. And GPT stands for, as you see here, generative pre-trained transformer. Now, the magic for LLMs lies in their transformers and a thing called attention. A transformer is also a name for a special kind of computer program that can understand and create different kinds of languages. Transformers are an advanced form of artificial neural networks, and we'll cover the basics of those in an upcoming slide. Transformers can read a story in English, for example, and summarize it in another language, like French. It can also listen to songs and create rhyming lyrics. In general, they predict what comes next in a sentence or a conversation and to respond to a user's prompt. A transformer can do this because it learns context, and it has a lot of memory and attention to do this. It learns context by meaning and by tracking relationships, or rather, it extracts meaning by tracking relationships in sequential data, like the words in the sentence I'm speaking. Memory means it can remember many of the words and facts that it learns. And attention means it can focus on the most important parts of what it sees or hears. Now, this is some of the magic that gives large language models its human-like qualities. It has intention units inside this transformer, and it's code inside the transformer. And what it does is it tags and follows words while computing like an algebraic map of how the tagged elements relate to one another. And if you want to learn more about transformers and how they work, I have a slide in the back of this presentation called Learn More, and it has many links in it for you to do your own research on it. But I'm going to, in the next slide, please. I want to build some intuition about how transformers learn context to demystify this thing a little bit. And so you can see two sentences here. As she wrote, ink flowed from the pen to the paper until it was full. In sentence 2, as she wrote, ink flowed from the pen until it was empty. What do you think the word it relates to in each sentence? Well, in the first sentence, the word it relates to the paper. And in the second, the word it relates to the pen. Transformers use attention units to learn such relationships. And again, to go deeper, I encourage you to see what is a transformer model in the Learn More slide. Next slide, please. So I included this video to give you an example of the difference between biological and artificial neural networks, so you can get a sense of how far apart it is from us. You can go ahead and hit play. Now, what you're seeing here is something called synaptogenesis. You see in the upper side of there, you have a free neuron and the network below it, and it's reaching out. It's trying to build connections with the network below it. And it does that for biological reasons. Now, next slide, please. Hold here. Thank you. Now, on this slide is as technical as I am going to get. And what you're seeing here is the simplest model of an artificial neural network made up of perceptrons. Now, I want to take a sidebar on this and give you a bit of trivia on the history. AI is not a new thing that OpenAI just came out with in 2021. So the perceptron was first developed in 1943 by a United States naval project, and it was intended for use in image recognition. If you want to learn more about this fascinating innovation, again, I'll refer you to the Learn More slide. There's a link to it. Okay, so hold here. So in here, each node is called a perceptron, and it consists of an input layer that receives data inputs, those are the X's, and from a vector or an array of data that you pass to it. The hidden layer is composed of nodes that receive input from the first layer of activated perceptrons. The final layer receives input from that middle layer and produces an output. So note here that all of these connections, the arrows, have weights or numerical values that are determined from the training step. The node with the little h is designated that way just to indicate that it is node 1 in the hidden layer, h hidden. Okay, so go ahead and click. I have some animations. Stop right there. Thank you. So what you see here is what's happening inside the H. So once all of the inputs are received in those little arrows that are pointing to the H, those inputs are multiplied by the weights, and all of those products are then summed and passed to an activation function. Here, the activation function is the sigmoid function I told you about. I'm not going to get any deeper into that. And then once that activation function does its calculation and fires, go ahead and click enter again. It produces this S-curve. Now, the utility of this S-curve here is on the vertical axis, you see probabilities or likelihood of an event happening. And you can set a threshold here. Let's just say, for example, we want to set a threshold at 70% or 0.7. And beyond which we want to indicate or have an output of 1, and below which we want to just ignore, like a yes or a no. Something happens. And that's the utility. That's all a perceptron does. That's exactly what it does. Next slide, please. So now here I want to address the skepticism and how skepticism arises from the phenomena such as the AI chasm, data drift, and data challenges, such as bias in data sources. These problems erode trust and prevent adoption and loss of investment dollars. Now, the AI chasm is a gap between engineering a practical sound algorithm, a solution, and using it for meaningful, relevant, real-world scenarios. I'll give you just a general example of what I mean. You develop a POC to make a prediction, let's say sepsis. And it works well in proof of concept, but then you release that into production and you have a vast array, multiple array of different demographics that it wasn't trained on. And it creates erroneous or false alarms. So in the proof of concept, you used a smaller data set that might not have represented all the data for all the people that it needed to do this for in all the conditions. You release it to production, and it has a different negative output, a disappointing output. So then you have to abandon it or turn it off. So that's one example of that. Data drift is when the production of data, it's when the production of data changes or shifts away in some subtle or overt manner from the data set on which it was trained. Now I'm going to bring up a sepsis example again. And there was one case, I won't get into it too deeply, where the sepsis algorithm was released and used, and it was working fine for a little bit, and then the demographics data changed over time and started creating spurious alerts, which eroded trust in the product, and so they had to turn it off and abandon it in place. And then for data challenges, it includes things like data quality problems from erroneous data, missingness, distributional shifts, which is change in the distribution from the population from which you collected the original data, and then data drifts. And then there are a couple of other qualitative reasons why we have these problems. And it could be a lack of clear business goals, use cases, or metrics for AI. And another one could be a lack of trust, transparency, or accountability in AI. So to learn more about the AI chasm, I have more links in the Learn More section. Next slide, please. Okay, so here is where I tell you about TRAIT, the theory of trust and acceptance of artificial intelligence technology, how it was developed, how it was validated and used to assess clinician trust in AI. TRAIT was developed at Memorial Sloan Kettering Cancer Center, and the population were clinicians that used AI-based applications with natural language processing and natural language understanding. Now, this is where, in this section here, is where we're going to connect our TNT in people to that in AI. And we'll also suggest to you how you may go about evaluating the end user's trust and acceptance of AI at your organization. So note, in the case of this theory here, user acceptance of AI is defined as their willingness to adopt it. Next slide, please. And hold. So as we said earlier, trust is a dynamic relationship that always is under scrutiny by the truster. The trustee's credibility, beneficence, and competence is what we scrutinize. Comparatively with AI, hit enter, please. We evaluate if we can bestow our trust in the technology based on its attributes of technological trustworthiness, comprising information credibility, its system performance characteristics, and its application value. In the case of AI, system characteristics comprise its reliability and adaptability, whereas application value is our proxy for competence, and it includes its usefulness, ease of use, and satisfaction with using it. Consequently, as in our human relationships, skepticism towards AI partners is natural, and at this juncture, it's healthy and necessary. So, next slide, please. So this is how I defined trust to validate my new theory against. And it is the extent to which a user is willing to be vulnerable to a system's actions, given that that system will perform some necessary action or set of actions without the ability to monitor or control that. And how did I do this? How did we develop this? Next slide, please. So we're going to do a way stop here before we get into trait and its model. And I want to explain exactly how it was scientifically developed and validated at Memorial Sloan Kettering Cancer Center. And first, the problem we identified was that clinician skepticism in AI is a central prerequisite to adoption. And if they don't trust it, they won't adopt it, and our money is wasted. So trait was developed to assess clinician trust and acceptance of AI so we can take actionable steps to improve the likelihood of adoption and maximize its investment. It was a two-phase study that included both, as you can see here, model development and model validation phase. And both of those phases included a factor analysis, which included exploratory and confirmatory factor analysis, partial least square structural equation modeling for hypothesis testing, and the Johnson-Neiman methodology to analyze the moderators. And to explain what a moderator is in a factor model, moderators are those things that control the strength of the relationship between your predictor, in this case trust, and the output, in this case, their trusting stance towards similar AI that we're evaluating, and their willingness or acceptance of the specific AI tool under evaluation. Next slide, please. Now, here is a graphical network representation of trait. And the final trait model that emerged from this study revealed that trust was strongly related to the AI application's information credibility, the system performance characteristics, and application value. And the model we found out discovered it explained a huge amount of variance in clinician acceptance of a specific AI tool and their general trusting stance towards any AI-based system. So what this means is that their trust is built on the perception of its information credibility, system performance, and application value. And that trust predicts how well, or that experience with that application, that AI application, builds their trust, and we can predict their trusting stance towards other similar AI application, as well as their willingness to use that particular AI application. And next slide, please. So it is a survey instrument, and it's easy to use. It's small. It consists of 13 measurement items, 3 role and experience items, and 4 demographics items. And the survey sample completed this on average less than 5 minutes to do it. So it's a very easy to use survey tool to get all these insights. And next slide, please. And the insights we were able to glean from this is from this primary example. And this shows you how we use the survey data to understand what was working and what might need attention to improve adoption and of the AI application. And as you can see here, the dashboard shows the aggregated results of our sample of 73 clinicians. The acceptable average score for any factor was set to 3 on our 5-point scales. And the application value and acceptance scores show that our clinicians did value and were willing to accept the AI-based tool that we evaluated for them, but they rated, and these were survey items, information credibility and system performance as unacceptable, which suggests they didn't find it entirely trustworthy. And then to find out why, we drilled in and found out that both the MDs and the advanced practice providers rated information quality, a survey item, and adaptability, another survey item, and ease of use as unacceptable. And we were able to, this basically represents how we were able to assess their trust, their perception of the AI tool, and map it back to its behaviors, which could then be mapped back to the features that gave rise to those perceptions. Next slide, please. All right. So here we're going to return to the learning objectives that we had at the beginning. And trust, we should have seen, is our willingness to be vulnerable to another, given our position, their position rather, agency and ability to act on our behalf. In trustworthiness, a person exhibits warmth and competence as a leading indicator of their trustworthiness. Conversely, AI's trustworthiness comes from our perceptions of those that made it and how well it works for its purpose. And as we learned earlier, the extent of our trust in both human and AI depends on how well each demonstrates its credibility, its competence, and its beneficence. For AI, its beneficence emanates from one's impressions about performance characteristics and usefulness for the use case in which it was intentionally made to serve. In evaluation, we just saw an example of how trait helps to understand humans' perceptions of AI's trustworthiness, and we can map that back to its functional behavior. So trait can help increase adoption of AI in that manner. Now, I will leave it to you for you to think about how you can use what we just talked about this evening and apply that to your professional and personal relationships to improve team cohesion. Next slide, please. And thank you very much. I am happy to take any questions that you might have at this time. I really appreciate all of you.
Well, thank you, Alex. That was a fantastic talk. Appreciate your time and taking us through your theory and then showing us this trait survey that you're using that really allows, as you were showing in the example, this understanding between a particular AI tool, whether that's a machine learning tool or a deep learning tool or some kind of generative tool, in relation to its users and how well the users trust that tool. And what happens, what actions does an organization take perhaps if you're starting to really see users aren't trusting an AI-based tool at all, or it's lost credibility, or how do you start to get into the root cause and what you might do if you want to improve that trust level?
That's a fantastic question. The way we decided to do it was to do it intentionally. And so we have something that's called an AI pipeline in the first place. So you don't just decide you want to implement an AI tool and then go ahead and implement it. The AI pipeline starts with first understanding what problem you want to solve with AI. And then once you develop that, before you even release it to the users, what we want to do is we're going to want to have some checkpoints along the AI pipeline so that we can evaluate two things. We want to evaluate the validity of the AI model itself. That comes with certain metrics. And then we also, at the same time, we want to evaluate a core set of users very early on that have been exposed to the AI, so we can actually go back and tune that AI model to work out the kinks very early on. So that's before it gets formally released into production. Once we go through that process and we've assessed both those things, then we can go ahead and then do a secondary validation to make sure we fix those things. And if they meet those criteria, then we release it to production. After that, what we do is every 3 months, then we will go ahead and we will do that assessment. It's something called, I didn't talk about here, and somebody else published on it, and I'm happy to share the link to the publication, called algorithmovigilance. And you watch the algorithm, you build in metrics in there to watch the behavior of the algorithm, but also you'll use my tool Trait to evaluate the trust and trustworthiness of that algorithm itself every 3 months for the first year, just to make sure everything is on par.
Interesting. Great. Thank you for that. No, that's really helpful to understand how you take this and from your theory and then put it into practice and use it. So it's really not it's not building trust into a specific software necessarily as you're developing it. It's just if we follow some certain steps, we're deploying something that's more likely to be trustworthy, and then we can monitor and make sure. So that's fascinating. So a couple of great questions from the audience as I'm looking over at our questions. One is just simply, if this were to be deployed in another spot, is it possible, or do you think it's possible to modify, or would one need to tailor some of the questions in the trait survey, depending on the users and the tool and some of those kinds of things?
Another excellent question. So some of the future research that I would like to perform, that I actually have planned in the pipeline, is extending Trait by testing it in other use cases outside of healthcare and oncology. I would like to test it in other healthcare scenarios beyond oncology. I'd also like to test it outside of healthcare. And so the way you do that, since this is a validated instrument, is to first use the instrument as is before you change it. That would be one way I would go about it. If we were going to use this in, one of the things that we would like to do is apply this in to health consumers. Those are people that are interested in having our health, exploring our health products, or patients. Patients are different than health consumers. They are patients. And so I certainly would say that the items, the way that I have in the validated model, the survey items, would definitely need to be tuned for health consumers and patients. And so with that said, I think that we would want to actually take a look at those items and revise those, go through a process to make sure that they were appropriate for those folks.
Great. That's really great. Thank you very much for that. That's really interesting. And I think for some of our audience members, that gets their wheels turning about, wow, this is not just sort of a one-off sort of thing. You can really tailor this and do stuff. And I guess audience members, if you have use cases for Alex, you should probably let him know. Alex,
I was just going to add, I would certainly enjoy people reaching out with their ideas and possibly even collaborating on future research on this. I would love to do something on this, using Trait to evaluate educational AI, for example.
fantastic. Well, I work in this organization called the Rise Lab, and we're doing work there. So we should connect also, Alex. That would be fantastic. So one of the things one of our attendees asked is, when we're thinking about trust and credibility in AI, and I will extend it to your trait survey, are there ways of, as trust is breaking down, we spot instances of bias that may be occurring in the models that are being used, whether that's a language model or some kind of machine learning, or is that a deeper, more technical dive once you just recognize there's a trust issue?
So trust begins at the data level. AI, I want to be clear, AI is beholden to the data that it's trained on. And with that said, its worldview, its perspective, everything it knows about the world is contained within that data set that it gets. And so we start building in trust by examining and handling and preparing the data the appropriate way. We have a problem in healthcare, I can tell you, from socioeconomical factors that impact the representation of people in data sets. Healthcare is very expensive and not everybody can afford it. And by virtue of that, it means that there are people that aren't in our data set that should be in our data set. Now, there are things like that are happening in healthcare. For example, There's a project called All of Us, I believe. I don't have the link here in my presentation, but All of Us is trying to, it's free participation. If you want to participate in that study, they want you to participate. And I think what they want to do is they want to get your genetic samples to add them to the database. They made it free so that there's no cost. It's not cost prohibitive to participate in that study. And they want to build out a large representative of everybody's genetic profile. And that's extremely important to research. If did I answer the question?
Yeah, no, I think you did. It was really getting at does this help eliminate bias? Does this reduce bias? I think the answer is every data set is always biased somehow. It's whether that those biases are skewing things in a really bad way, and that can be demographically, it makes the system trustworthy, perhaps would be a way to say it, because it's skewing things in a biased manner.
That's exactly right. And so with our human users, in this case, our clinicians, if we release an AI tool that seems to not be providing the information credibility, and that's related to bias, our talented clinicians should be able to get a sense and detect that. And that could start, the whole thing behind trait with respect to that piece of it is that it can start a conversation around the trust and trustworthiness, which could actually lead into discussions around the bias. Why is its information not credible, right? I'm seeing this, I should be seeing this, and this is related to bias in the data, and so that's one of the value propositions of trait itself, is it starts the conversation around, the trustworthiness of AI from all angles, actually.
Fascinating. Thank you. So yeah, we are, as Heather's noted in the chat, we are nearing the end of the set time. Alex, I assume you're okay to stay around for a few more minutes and take a couple more questions.
Oh, sure.
Yeah, that's awesome. Thank you so much for your willingness to do that. And yeah, so anybody else who has some questions, we'll see if Alex I'll pull a couple here and keep going. How do you feel leaders should coach around responsible use of AI? So we have a lot of general things in here. So how do you think leaders should coach around responsible use of AI so they can move to using it as a collaborative partner? And that's I like this question because you started with leadership. You moved into trusting in AI. Now this question has brought us back around to leaders and their relationship with those tools. So
Absolutely.
Yeah. So
that's a great relationship. That gives me an opportunity to share the framework that I'm working on with respect to AI. And it's what I call the FASTER framework. And that stands for AI that is fair, safe, trustworthy, while ethically designed, ethically governed, and responsibly used. And the responsible use of AI comes from how you train your user, what you design it for. So responsible use goes all the way back to the leadership in the organization. Why are we going to use this particular AI solution? Is it right? Is it safe? Is it protected? Are we following the ethical guidelines to implement it? Are we following the data safety and privacy guidelines? First of all, do we have those protections in place? And do our people understand how to use this, what its limitations are? And so I do believe that leadership has a great responsibility to make sure that AI is responsibly implemented and responsibly used.
excellent. And they get trusted as well. What are some valuable and trusted AI applications in use today at Memorial Sloan Kettering? Question out of the audience.
I'm sorry, I was typing. Can you ask me that again?
Yeah. What are some valuable and trusted AI applications in use today at Memorial Sloan Kettering, where you're based?
Oh, that's a fantastic question. We have many. We have some that predict the likelihood of mortality within 45 days. And talk about responsible use as a sidebar on this particular one. So not only did we have to be extremely cautious and careful with our development of this, because if you predict mortality in 45 days for somebody, and then you inform them of that without being absolutely clear that this is true, you can cause grave harm to the patient. You can cause financial problems for the institution, et cetera, et cetera. So we had to expertly develop this, implement it, train people on how to use it, and then validate that model. And so all of those aspects about being responsible, ethical in its implementation and training came into play here. So I guess that one is near and dear to my heart. One of the other ones that we're actually, I think, looking at as well is ambient AI. And so we have so that's of great interest to us that we're looking at implementing, because clinician burnout is prevalent in healthcare globally and nationwide. But I can give you an example. Let's say you're a physician that wants to, that sees patients for exams on a daily basis. We fill up, the 15 minutes that you have with a clinician, that's the money shot for you as a patient. That's all you care about. And that's the money shot also for the institution. That's where our integrity comes into play. That's how we help patients. And so when you're looking at numbers such as having less than one clinician in oncology per patient nationwide, that's huge. That means there's a huge demand on clinicians to see patients. And so we fill up maybe 4 patients per hour. And you got 15 minutes in an hour. When are you going to get a chance to document, right? So there's something called pajama time. And so clinicians, when they're done with their day caring for their patients, they go home, and before they eat dinner, or maybe they eat dinner and see their family for a few minutes, they spend pajama time doing their documentation. And so ambient AI could be extremely helpful. It will listen to the conversation between the doctor and the patient, and it will make those notes and update the clinical record. And so all the physician would have to do, ideally, is go in and validate those notes and accept them, or make any changes that they need to do, edits they need to do, and then accept them. That's another one.
Thank you for sharing that. That's fascinating. You're mentioning your mortality tool. By the way, the audience might like this. The fact I came across today. I was reading Ed Week, and there's a study that's been published, by the way, that if you didn't know this, by completing 18 years of education, so K-12 plus 4 years of college, it cuts your adult mortality by 34%. So that's a little off topic, but I figured since we have an audience of alumni, they'd like to know that their education has some benefits they may not have been aware of. So
You reduce your mortality and prolong the quality of your life. 2 thumbs up to higher education.
Yeah, absolutely. All right, let me see. So I have a lot of questions around people coming back to academics. I think that's a common area, I would assume, for a lot of this audience. But I'll ask a very general kind of question here around it. But how would you envision, or would you envision it being significantly different to apply what you've been doing in healthcare in academic applications of AI? And there are a host of those, from ways to understand how student behaviors are happening based on how they work in LMSs, to there's lots of students who are using AI tools, and in fact lots of professors who are engaging AI tools in classes across higher education right now to either help develop ideas, creative buddies, those kinds of things. Some of those tools are sort of, the toothpaste is out of the tube. They've been released. They weren't necessarily developed in sort of the responsible ways that we're aware of, that you've been advocating for. And some of them, different education institutions will have the opportunity to develop those in these kinds of ways. So that's a big big undefined area I'm kind of scoping out, but how do you wade into that maybe from your focus in a different profession and kind of start to think about, hey, this is how I might come at it, or this is how I might see applying this this trustworthiness approach into higher education and its adoption of AI tools.
Absolutely. That's a fantastic question. There's two approaches I would take to that, first of all. So if I heard you right, there is, there's a lot of risk with certain AI products out there. And if I was in a higher education and I wanted to use AI for something like leveling the playing field for let's say for hearing impaired people, I think that you could use today any kind of product that's a large language model, for example, to be able to listen to the conversations that are going on and present that readout to the hearing impaired person, for example. And so, that would be one advantageous way, one strategic way to actually increase the availability and the accessibility to this to people that otherwise might not be able to attend. If we were using that here, for example, we might be, and there was a hearing impaired person on the line, they might have a unit that's next to our pictures, and they can see all of the conversation that we're talking about, who's talking about it and when, and be able to actively participate in the chat with us, for example. However, there are risks with those kinds of tools as well. And we need to, if I was higher education, the first thing I would want to do is I would want to understand the risks. I would have something like an AI task force, like we did at MSK, to evaluate advanced technologies like large language models, any kind of AI, to understand what the risks are with it really clearly. And then once we decided to go with it and choose a product, understand the risks of those products so we could take action to mitigate those risks. That's what I would do. But I would always go with it at a point where, yes, these things have some risks. We need to know what they are. But the strategic advantage of this is X, Y, and Z, and this justifies why we want to go with this. And then that's how I would probably approach that.
Yeah. So if I heard you right, you really, especially in higher, if I'm helping students be more successful, if I'm helping them learn better, if I'm providing access to people who don't have access to education and they can now participate in new ways. I've read recently that in about 10 years they're going to have Babelfish capability where and if that's, and for those of you who don't know, Babelfish capability means AI will immediately translate languages for people. So there's this potential that people who speak different first languages could actually be in classrooms together. But what are the risks involved with that, and how do you decide to wade into those things? So it's been fascinating talking. Oh, go ahead. Sorry.
Yeah, I was just going to close with, outside of healthcare, where I find lots of satisfaction and value. Education is very meaningful to me. I was an adjunct professor at Baker College, and I taught computer science. And if I wasn't in healthcare, I certainly would be in higher education as a teacher, as a professor, because that is a gift that I experienced myself. I'm still in contact with my students today. I can tell you, one made it to CEO. Some others are, very high up in leadership of what they do in IT, for example, and they consider me a mentor. And it is a gift that exceeds temporal and spatial boundaries. You can see it, and it's so rewarding. And so I just wanted to close with that. I really appreciate everyone's time here. I'm extremely honored and touched that you hung in with us. And thank you very much for listening.
That's great. That's great, Dr. Stevens. My honor to moderate with you and just have some conversation. And thanks for all you shared with us. And I'll hand it back to Nancy.
All right. So that was an absolutely fascinating conversation. I am not a techie or in innovation like Steve and Alex, but I really appreciate that you spoke about the topic in kind of layman's terms so we could all look at exploring AI and the applications. And I love your theory. And, just appreciate the patience for all of you on the East Coast, especially our moderator and speaker, because I know it's getting late there. But thank you so much for your time. We, Dr. Stevens has been generous in providing his contact information here. I'm sure that for those of you interested in AI, you definitely are going to want to make that connection. I understand why students of Alex's are interested in staying in touch, and I think you would be an amazing professor in this area. Just so much to learn, and it's such an exciting topic that is relevant to all fields, but it's important that we have individuals like you and Stephen that really understand the potential risks, but also building trust and all of the advantages from this area. So just in closing, I'm pleased to share we will be having another speaker series next month with Dr. Tom Stewart. Also, we have some upcoming events with the National University Mentoring Network, which is intended for students or alumni interested in participating. We've got some upcoming association meetings, as well as a joint student and alumni event on February 29th on Vibrant Voices. So please join us for a future speaker series and our other events. So appreciate the National University alumni team that helps coordinate our speaker series. And again, special thanks to Dr. Alexander Stevens as well as Dr. Stephen Johnson. Truly appreciate both of you. Thank you.
Good evening.